Hi everyone, welcome to the Chapter 1 Problems, or the most missed problems from last semester. Hopefully you can come and just check your answers from mastering. Be sure you work the problem in the same format. Or if you're struggling with this problem, you can come and watch the video and hopefully it will enlighten you and you will understand it. Alright, the only difference between these problems and the mastering, they're the exact, pretty much same problems. Well, they're not exact, they're very similar, but they just may have, here I've got, you need 4 ounces of a steroid ointment, whereas mastering may say 3.2. Okay, just wants you, they want it to be exact so that you can go back and work the problem for mastering and be sure you can do it, that you don't just come here and get the answer and be done with it. Okay, so I want you to work the problem for mastering, if you haven't already, after we go through these. Okay, so this comes from Chapter 1.9, Problem Solving. So this is really your more complex, more complicated problems because you're using conversion factors, but you're using, more than 1 or 2 of these, and the problems are longer. So students tend to struggle a little bit more with these. Okay. So if we look at the problem, you need 4 ounces of a steroid ointment. If there are 16 ounces in a pound, how many grams of ointment does the pharmacist need to prepare? Okay. The first thing you also want to be sure you have is your conversion factors list. Okay, I have this on Blackboard for you, I think in 2 different places, and you have also the same thing in your book or something similar. Okay, so the first thing you do is you want to start with what you're given, so what we know here. Okay, so we've got 4 ounces. Okay, so we know we're going to have ounces on the bottom as well. Okay, and so basically you have to come up with your path. Like, how are you going to get from ounces to grams? So you would look at your conversion factors list and see, okay, well, here I'm given a way for me to get from ounces to pounds. Okay, so we're going to use that. So we have to say 16 ounces in 1 pound. Now remember, we have to put our conversion factor this way so that our ounces will cancel. Okay, so now we have pounds. So if we were asked for pounds, then we would be done, but we're asked for grams. This is what we're going to. Okay, but we know we have to have pounds on the bottom. So if you look at your conversion factor sheet, we do have a relationship. So that's what we're doing. We're finding relationships between these different factors. Okay, and so we look and we see that there's 1 pound. In 1 pound, we have 454 grams. Pounds cancel, and we're now left with grams. So if we do the math, you multiply everything on the top, so 4.0 times 454 divided by 16 times 1, we should get about 110 grams of ointment, or of steroid ointment that we would need. It tells us that we want 2 significant figures. Okay, so just a reminder, we have 2. We have both ones. Any non-zero digit is significant. But we have a 0, a trailing 0 with no decimal there. So that 0 is not significant. So the 2 ones are significant, which gives us 2 significant figures, which is what we are supposed to report the answer to. Okay, problem 1.60C. It's a little bit more difficult for some of the students because we're using a percentage. Okay, what you want to remember is that a conversion factor from a percent just means that there's so many parts per 100 parts. Okay, so it's always out of 100. Okay, so that's what a percentage is. Okay, so what we're going to do here, so we've got that a wine is 12% by volume of alcohol. How many milliliters of alcohol are in 0.750 liter bottle of wine? Okay, so the bottled wine contains more than just alcohol, right? Because it's just 12% alcohol, but there's other ingredients in there. Okay, so we have to, first, we're going to take our 0.750 liters, and this is of the total bottle. So if you want to look at it as total, or the total contents of the bottle. Now I'm out of order here. Total contents of the bottle. And we need to go to milliliters. So that's what we're going to do first. And then we'll use our percentage at the end. Okay, because that's what we're really trying to find. We're trying to find how many milliliters of just the alcohol is in the bottle. Okay, so if we go to our conversion factor sheet, we see there's 1,000 milliliters in a 1,000 milliliter bottle, so the total bottle. Okay, we have 1,000 milliliters in 1 liter. So now our liters will cancel. Remember, for our dimensional analysis and our conversion factors, we set everything up so that we can cancel diagonally here. Okay, so the next thing we got to do, so now we have the milliliters of all of the contents of the bottle, but we want to know how much of it is just alcohol. Okay, so what we do is we look at this as basically saying we have 12 milliliters of alcohol in per 100 milliliters of the total contents of the bottle. Okay, and so since we've been this one conversion was including all the contents in the bottle. Okay, and so this 100 milliliters needs to go in the denominator because it includes the total contents of the bottle. But out of 100 mils, since the percentage is out of 100, 12 milliliters is just alcohol. Okay, so once again, milliliters, but not just milliliters, it's milliliters of the total bottle, however you want to write that. Okay, but we're looking for just the alcohol content. Okay, and so in milliliters. So we had to convert to milliliters first, and then use our percentage. Okay, so if we do the math, you should come up, we want to have 2 significant digits. Okay, so we should come up with about 90 milliliters of alcohol is in a 0.750 liter bottle of wine. Okay, and like I said, your numbers will be a little different on mastering, but the same idea. And we want 2 significant digits. It tells you to report to 2 significant digits. Therefore, we have to put a decimal place after the 0 to hold that place, to make that 0 a significant digit. So we have 2 significant digits in the problem. All right, this concludes problem 1.60. Thanks.